Hi everyone, welcome back to my channel. So in this video we are going to understand about horizontal scaling and why do we need a stateless architecture in horizontal scaling, what are the problems that we could face with stateful architecture, and I'll also explain what is stateful and stateless architecture and why do we need a stateless architecture in horizontal scaling. So let's start. If you remember, in our last video we saw about vertical scaling and horizontal scaling. So in vertical scaling, what happens that we have a single server. So when you like, let's say your service is growing too much, your application is so much famous that lots of users are have started using it. So you are getting lots of requests on your server, and your server is not able to handle all those requests. So what do? You started increasing the server's capacity. So what do? In a single server, what do? Like, you increase its CPU memory, and if you are making a single server powerful, like by increasing its memory power, so this is called as vertical scaling. So what happens in vertical scaling, that you will reach at some point of time that beyond that you are not able to increase the memory. So this is why in distributed systems we move to horizontal scaling. In horizontal scaling, we don't have only single server, we have multiple servers. And what do? Like, multiple servers we have, and these servers are responsible for handling users request. So how do you distribute the request among these servers? So for that we have load balancer. So here, this is user will make a request. It will not directly make the request to server, rather what happens, it will go through load balancer. This is load balancer. Now it's the responsibility of load balancer to route the request to server, and we will talk about in detail like what is load balancer, how does it work, how does it choose which server it should route the request. That we will see in some other video. Right now we are not focusing much about load balancer thing, but in rough idea, just remember this thing, that it's used for routing the request between the servers. So what do you do in horizontal scaling? Rather than making a single server very powerful, you have identical multiple servers, and you are using load balancer to distribute the traffic among them. Now you will see, okay, if I will add more server in my system, then I will have better scalability, but this is not the case. So what happens that so what the problem with having multiple servers? So what happens that whenever user is making a request, it will pass to the load balancer, and then let's say you are having multiple servers. In this example we are using server 1 2 3. So let's say what happens that whenever user is interacting, so user have some data like its login data, session data. So all these details are getting stored into the server to which the user is interacting. So user information is stored inside the server, and these information are stored inside the server locally. Okay, so this server 2 doesn't have any idea about users information, whatever is there in the server 1. So what happens, let's say one time user made the request to server 1, and it did some processing and all. Now next time when it is hitting the load balancer, and load balancer chose server 2 this time. Now server 2 doesn't have any idea about the user, so it may not authenticate this user to use the services, the resources it have. So what happens that in that time user can face login issues, right? Because the server will not authenticate that user. Server 2 doesn't have any idea about that user, its session data and everything. User state it doesn't have. So what happens that due to this problem we will get session lost. Yes, server 2 doesn't have any idea who this user is, and due to this user can face logouts, and it would be a very broken experience for user. So whatever the situation that we just discussed, it is of stateless. Okay, in a stateless architecture it can happen. But if you see in a stateful architecture, so in a stateful architecture what happens, this load balancer is responsible for managing user state. So if I'll show you, so what happens that load balancer maintain the sticky sessions. Like whenever user is sending some request, so it will route the request to server, and to which server it routed the request, it will store the session details here, users information in here, like inside the load balancer only all the details will be there. So let's say like here it's written that server A handles user A and B. Let's say user A and B, every time they will make a request, it will route to server A only. Server user C, anytime it is making any request to load balancer, it will always route to server B. So all the session, user state, everything is maintained inside this load balancer. So load balancer has those information to which server I need to route for which particular user. Okay, so what happens that here you can see user and server both are tightly coupled here, like user and server, so these are tightly coupled. Okay, so what happens that due to this, like we are having, like you could face the difficulty in scaling the system. Okay, and like if anything happens to a server, like server is crashed, server is not available, some downtime it's facing, so in that scenarios, like it will affect the user, because users all information was there inside that server only, and now that this server is not working anymore, and due to this you may face these kind of situations. So these are the problems that you could face with stateful architecture. So now what happens in stateless architecture? So in a stateless architecture, rather than storing the user state inside this load balancer, what do? We have a shared resource, like externally shared resource, that each server can access. So in the like shared space, this is a cache. You can say this is Redis. Let's say Redis we are using as a cache. So you store user state inside the shared space, and both server, like here we have, like all the servers can access that space and take the users details from there. Now how do we authenticate the user? Now load balancer doesn't have this load that I need to manage user session. No, it's not load balancer's responsibility anymore. This responsibility moved to this cache layer. So we will discuss about cache, what it is in detail in some other video. Right now we are not focusing on what is cache. Just understand cache is maintaining the mapping, which user is connected to which server and what is the state and information of user, that kind of information it has. So like how do we authenticate the user in a stateless architecture? That then, because how the server will identify whether this user is genuine or not. So for that purpose, how do we achieve? It's JWT based authentication. So how does it, like JWT is JSON web token. So how do we achieve the authentication through this token? So let's say user, this is client or user you can say. So user is sending the login request to the server for the first time, let's say with username and password. So this time server will create the token, and it will pass this token to the client. Now this client will store this token, and next time whenever it is making any API call, so it will pass this token in the header. Now it made the request to server will fetch the header. Inside the header it will extract the JWT, and from JWT it will extract the user information, and then some validation logic will happen in the backend, and once the server validate the user, okay, this user is genuine, then it will send response back to the client. So this is how the user authentication for the auth mechanism through JWT happens. So okay, so now we know that why do we need this stateless architecture, because we don't want to bind user with particular server. No, we could have multiple server, and each server should be responsible to handle any kind of request, so that we can scale our system very easily. Okay, and we don't want to bind a user with servers. This is why we need a stateless architecture. So stateless architecture allow any server to handle any request. Okay, so there are lots of benefits. If we see, yes, true scalability, like at some point of time, you are getting lots of requests, your user base is increasing very high, so you need to add some more server to handle those load. So this won't be any problem, because any user information is not binded to server. Any server can handle any user's request, so you would be very like feasible in implementing those mechanism. So you can easily add the server, you can easily remove the server. Any server is down, let's say downtime it's facing, you can remove that server and it won't affect the user. Like this user, any other server can handle that user. Okay, now fault tolerant. Let's say if any server is crashing, so it will not impact the user, because that user is not binded to their server anymore. Their request some other server can handle easily. Now yeah, simple load balancing, because now load balancer doesn't have any overhead to manage user state. No, this responsibility we have taken out and passed it to some shared space, so they don't have to maintain the sticky session and all. So very simple load balancing. And also the deployments will be very easy, because user and servers are not very strongly bonded to each other. Okay, so that was all about the stateless architecture in horizontal scaling. I think I have covered all the points. So okay, that this is it for this video. Please let me know what topic you want in next video. I will try to make video on that, probably on load balancer or cache, maybe we can. But let me know if you feel any other video I should make, so I'll do that. So thanks for watching. If you like this video, please like, subscribe and comment. Thank you.